For our last video reviewing the properties of logarithms, we're going to look at the one-to-one property. This is what allows us to solve logarithmic equations that have logarithms on both sides by finding a common base and canceling. Now you might be tempted to say, all three of these have the logarithm in front, we can just cancel, but we can't. We can only cancel bases when we have a single logarithm on both sides. So we need to use what we've reviewed previously to condense our logarithms before we can do that. So the equation we're solving is log of x plus log of 3x equals log of 12. Now remember, when we don't specify the base, we're using the common logarithm, and the base is implied to be the number 10. So to start us off, let's use the product property to combine these two logarithms. So we'll have log of x times 3x. But I'm just going to write that as 3x squared. And this equals the common log of 12. Now that we've reduced this expression to a single logarithm on each side, we can cancel them. So we now have 3x squared equals 12. And this is a quadratic equation that we can solve fairly simply. So let's divide both sides by 3. And so we have x squared is equal to 12 divided by 3 is 4. And then we want to find the square root. So the square root of 4, it could be 2, but since we're solving an equation, it could also be minus 2. Now I've run out of space, so I'm going to erase this really quickly, because there's one more thing we have to be careful about. Like square roots are undefined for negative numbers, logarithms are also undefined for negative numbers. So because we have two different solutions, we need to check that they work. And so first, we're going to plug in 2 into our original equation. So if x equals 2, we have log of 2 plus log of 3 times 2 is 6. These are both positive numbers, so everything checks out. It's defined, it's a solution. But if we plug in x equals negative 2, we have the logarithm of negative 2 plus the logarithm of negative 6. And logarithms are undefined at negative values. So this expression is undefined, which means x equals negative 2 is not a solution. So the only solution for this equation is x equals 2. And this has been an example of how we can use the one-to-one property of logarithms to solve a logarithmic equation by canceling a logarithm with a common base on both sides.